So guys, we have successfully completed module one. We have discussed what are the introduction part, core microservices, clean architecture, DDD. We have also completed successfully write our real-time e-commerce application. So we have started from the project setup, and we have also completed all the required modules like user module, payment module, product module, order module, as well as the notification module. So all till now, we have completed our application development without using core microservices principle. Yes, the architecture what we follow is basically related to microservices architecture as we have developed different services and they are going to communicate with each other. But now what we need to understand the core microservices concept, how we can use those concepts in our application. So today we are going to start our module 3. In today's session, first of all, I will discuss what do you mean by inter-service communication, what are the different approaches are available. Then I will discuss a brief introduction to RabbitMQ architecture. What is this architecture? How you can download and install RabbitMQ server on your local machine, how you can configure the same on your Windows operating system, how you can view the user interface of RabbitMQ. And then another two session I will take. One session I will take to make you understand the RabbitMQ features, that is what are available within the Rate web application, RabbitMQ user interfaces. And then I will show you also how you can integrate RabbitMQ within our .NET Core application. So three sessions I'm going to take. Uh, One for you can consider introduction, setup, configuration, all these things. Another one, understanding the RabbitMQ services. Another one, integrating RabbitMQ within our e-commerce application. So if I'm going to explain means, I will give you the enough information. Also, I'm going to discuss the possible interview questions in today's session. For example, if you are going for interview, and if you mention you know RabbitMQ in your CV, then you might get some questions related to RabbitMQ. So, what are all possible questions that are being asked in the interview? That is also what we are going to cover in today's introduction session. So, let us proceed and understand this chapter 11. It will take three sessions as I mentioned. So, let me start with the introduction. So, inter-service communication. What do you mean by inter-service communication? See, inter-service communication, it is refers to the mechanism or you can say protocol through which microservices exchange data and coordinate actions with each other. So what do you mean by this thing? See, whenever we are developing microservices means what? Multiple services. We can have, if you take the example that what we developed this application. So how many services are there? Notification, order, payment, product, user service. So five services we have developed, or five, you can also consider five microservices we have developed. And if the application wants to function perfectly, then what we need all these five microservices to be collaborate with each other in an efficient and easy manner. So for this purpose, what we need to do, we need to communicate among these microservices. And this communication between the microservices means for what purpose? Purpose is exchanging the data and the information. Purpose is coordinate actions with each other. Sometimes we need to pass some data to other microservices. Sometimes we need to retrieve some data from other microservices. Sometimes we need to give some instruction to other microservices to do some operations, right? So for this purpose, what we need an efficient way of inter-service communication, right? For example, if you take the example, user microservice, what is the purpose of this microservice? Managing the customer's authentication and profile data. We have already discussed all these things. What is the use of a product microservice? Managing the product catalog and inventory. Same in the case of a order, managing the shopping cart, order life cycle. Payment is related to the payment functionality. Notification is basically related to send the email, SMS, and enough notifications, right? So with each services, they are running independently. Yes, we developed them, and that is the benefit of a microservices. Why we develop microservices? Because we want to not only develop them independently, but we also want to deploy them independently. So that is the reason why we introduce microservice. What is the benefit? Scalability. So we can scale one independent microservices without scaling the other. But when it comes to real-time business outcome, suppose you want to place one order. If you want to place one order, then that placing order is require multiple services to be work together. See, if you are placing order, you need to verify whether the user exists or not. You need to verify whether the product exists or not. You need to create the order. Once the order is completed, you need to take the payment. If the payment is completed, you need to communicate with the product service to reduce the inventory. You need to communicate with the notification service to send the notification. See, one business functionality, but that is going to be related with multiple services. If these services are not working together, then we cannot implement that functionality. And this is where inter-service communication comes into the picture. If you take the real-time or layman example, think of a company with different departments. So if you're working in a company, any IT company, then you know there are different organizations, different departments are there: sales department, billing department, customer care, right, admin department, HR department, infra team. So different right departments are there. So if they all work independently, right? So definitely all this department, their role and responsibility is going to be independently. But when some event is going to be occur, they need to be collaborate with each other, right? For example, if you take the example of a warehouse, sales team is there, warehouse team is there, billing team is there, customer care is also there. So they are all working together. So how these different teams are going to communicate with each other? So mostly it is based on the phone calls, emails, chats, and meetings. Similarly, microservices communicate through how? Microservices communicate through APIs, events, and the message protocols. Clear? See, if we are working in one company, multiple departments are there. How you will communicate with each department? We can communicate with each department via call, via email, via meeting, via chat. Similarly, when microservices are there, and if you want to implement a single functionality, and if that functionality require multiple services to communicate each other, then how the services are going to be communicate? Via API. Yes, HTTP REST services are there. You can use HTTP API. You can use events, and you can make use of a message protocol. Clear?
Yes.
Right.
Yes.
Now, let us understand why do we need inter-service communication with an example, right? For example, let's take our example, what e-commerce application we develop, right? So a customer place an order. So when a customer place an order service need product service to confirm the stock or not, whether how many stocks are available and how many stocks the customer wants to purchase. That purchase stock should be less than equals to the available stock. So verify this thing, the order service needs to communicate or needs to get data from the product service or not? Yes or no?
Yes.
Similarly, once the payment is successful, payment service must notify the order service to mark the order as paid. And once the order is shipped, then also we need to send or we need to trigger some kind of a notification, right, to the customer. And for that purpose, we need to deal with the notification. That means the order service needs to trigger the notification service to send the notification details or not. Yes. So without effective communication, the user breaks down. Imagine placing an order that doesn't check stock. Suppose you are going to place the order, and if you do not verify whether the product stock is available or not, so there is no stock and you place the order, what will happen? Customer buying some unavailable items. Payment success, but not reaching the order service. So we take the payment and payment is successful, but we didn't inform the right order service that the payment is collected. Then what will be there? So our payment is success, but order is going to be in pending state, right? No notification sent, right? For example, the order is placed. We are not sending any notification that your order is placed, your payment is collected, your order is cancelled, or your order is going to be delivered in this date, and your order is out for delivery. So if we are not providing this information, then what will be there within the customer's mind. So intercommunication, inter-service communication is the backbone of a microservices ecosystem. It makes independent services work as a unified system. Right? They are independent, or they are going to be work like a unified system. Clear? Clear or not?
Yes.
Okay. So what are the different types of inter-service communication? So there are basically two types of inter-service communication. One is synchronous manner. Another one is asynchronous manner. Sir, what do you mean by synchronous and asynchronous? Now, in case of a synchronous manner, we will send the request and we will expect the response from the service. Synchronous means as a right client, I will or as a right what I can say client, I will make a request to the server. Server will return me some response. For example, right? If you take the example of a synchronous communication, right? In this case, the caller service send a request to other service and blocks execution until it receives a response. The outcome of the request directly impacts the caller's workflow. So basically, for example, if you take the example of a real-time phone call, you dial a number, wait until the other person picks up and talk only. After the call ends, you can move on. See, if you are calling one person, if that call is not ended, can you call another person? Yes, you can do. For that purpose, you need to hold this person. But if you don't want to hold, right, then what you need to do in generally, you call that person means you have to, once that person pick the call, you have to talk and then only you can end the call. Then after you can call another person. So in that case, what happening? Now you have to wait till that call is ended. So similarly, in case of a synchronous communication, the caller send a request to the server, or you can say one service, service A, make a request to service B. So until and unless service B responds, service A cannot do some anything else. For example, if you take the example of order processing. So whenever I'm going to place the order, I will check whether the stock is available or not. So for that purpose, order for service make a call to the product service. So until and unless the order service didn't get response from the product service, can you place the order? Can you do the rest of the work? No. So this is nothing but your synchronous communication. Whenever the response is immediately required, without that response, if I cannot proceed further, then for that purpose, you need to go with the synchronous communication. Clear?
Yes.
So what are the technology you can use? You can use REST API, you can use gRPC. So REST API we have already discussed, right? If you take the example of order service, right? In the order service, in the infrastructure layer, here you can see notification service client. Here you can see product service client. So here you can see I'm using HTTP based services. Clear? So in this case, once I make a request to the server, right, from this order service, I make a request to the product service. Until unless I'm not getting the response from the product service, I cannot proceed for. Clear? So this is nothing but what I can say. This is nothing but your synchronous communication. See, yes, here we are using asynchronous programming. That is fine. Asynchronous programming means our thread is going to be right available for other tasks. But until and unless, as I have used this our keyword, until and unless I'm not getting the response from this API, I cannot proceed further and execute the rest of the code. Clear?
Yes.
Yes, sir. Yes. So this is going to be your synchronous. Another one is GRPs. So currently I'm not discussing anything related to GRPs. Why we are having a separate chapter, and at that time I will discuss this GRPs. But for now, you can consider this synchronous communication we have already implemented in our application. Now, if someone asks you when to use synchronous communication, you have to tell. So whenever the data is required immediately, without the data, if my service cannot proceed further, Then in scenario like this, we can go with the synchronous communication, and you can get this order example. Clear?
Yes.
Clear?
Yeah.
Now,
Yes.
next, what we need to understand the asynchronous communication. That is the backbone of read this microservices. See, in case of a asynchronous communication, the sender doesn't wait for a response. So in this case, sender will send a request, but he will not wait for a response. So instead, it publish a message. So in case of asynchronous communication, the sender doesn't wait for a response. That's right. So in this case, the sender publishes a message or event to a message broker. So in this case, message broker will come into the picture. The sender will publish that message to or event to this message broker. So message broker means you can consider this thing. These are the message broker: RabbitMQ, Kafka, Azure Service Bus. So in our syllabus, these two things are included. See, Azure Service Bus. If you are learning Microsoft, right, Azure, then you can learn this thing, right? For now, all right, we are going with these two approaches. Third approach is also available, right? So what is this? So if you take the real-time example, suppose you are sending a WhatsApp message. So once you send the WhatsApp message, are you staying online whether that message is received by the right recipient, your friend, whoever, whether he read the message or not, whether he is available online or not. So are you going to stay, or you just send the message and whatever your work you are going and you are doing? So in this case, right, the receiver reads and responds when they are ready, not when I'm sending. So I'm sending the WhatsApp message. That doesn't mean the receiver is going to read them immediately. Sometimes they might be read immediately, but it basically depends on their availability. So the receiver will read the message and respond when they are ready. Clear? So if you are calling, if you are making a phone call, that is synchronous. But if you are sending WhatsApp message, that is asynchronous communication. In synchronous means you cannot do anything else until and unless that call is not ended. But with the WhatsApp message, you just send the message and bother not. You are not bothering about whether the receiver reads and reads. Clear?
Pranay, I have a question. Hello.
Please. Yeah. Ask me.
So Pranay, can we handle that situation that you have talked just before, when we are placing the order, so we have to check that the product is available or not. Can we handle this situation in the RabbitMQ?
Please, you just tell me. So in this case, so RabbitMQ, what is the main objective? What type of a communication is this?
Basically, it is for the asynchronous communication, which is not
Asynchronous communication means what?
basically the
The sender doesn't wait for a response. So now
okay.
you just tell me, so whatever the API we developed here, if we send a request and we don't wait for the response, can my application work? Is this going to
No,
happen? Right?
no,
Is that a good scenario? No. So that
no.
communication needs to be synchronous. So when it comes to asynchronous communication means when the sender doesn't wait for a response. If it wait for a response, definitely that is going to be synchronous. No, doesn't wait for a response means asynchronous. So I will give you what is the real-time use cases of this asynchronous communication. Don't worry. But that example you cannot implement using RabbitMQ and the
Okay.
clear. For time being, is that clear?
Yes, yes.
So now, what are the common technologies we have already discussed? One is RabbitMQ. What is RabbitMQ? Detailed information we will discuss. Kafka and Azure Service Bus, AWS, S2S. So these are also available for implementing this asynchronous communication. For example, customer place an order. Order service publish an order placed event. A customer place an order. Order service publish an order placed event to a message broker. So this order place event is going to be consumed by multiple other services. One, payment service, who is going to initiate the payment. One is notification service, which is going to send a order place notification. Another analytic service, which is going to update the dashboard. So at the same time, you can also include here product service. What is the job of the product service in this case? It
To update the product.
update the stock quantity. See, updating the stock quantity, if it delay by few seconds, that's fine. But before placing the order, it must be right. You need to be right very carefully. You need to check whether the stock available or not. But after placing the order, right, if it is delayed by few seconds, right, that's fine. Right, it is going to update the stock. But while placing, it is mandatory to check whether the stock available or not. For that purpose, you need to go with the right approach. You need to go with the clear. See, in this case, the notification service is very fine. So notice, so basically some kind of a notification, or you can simply consider the service whose response not immediately required are good candidate for RabbitMQ and Kafka. Clear?
So, Pranay, in this example, I think payment service is also
See,
uh,
there are two things you need to consider. So when payment service means my order service make a call to the payment service, but he doesn't wait for the response. Payment will be initiated in the backend, right? And the order service return to the client. And now client, by taking the order ID, he will make a request to the payment service to process the payment. But at that time, that payment is already initiated. If it is already initiated, that is fine. Clear? See, that basically depends, right? How you are going to right initiate the payment,
okay.
right? If you are not immediately initiating, but if your requirement order service should do the right payment initiation in a synchronous manner, then in that case you can remove this thing. Clear?
Yeah.
Okay. Now, so sending WhatsApp message, this is the real time, or you can say layman example that what you need to understand. So key difference: synchronous communication requires the sender to wait for a response. Example REST API. In contrast, asynchronous communication allows the sender to continue without waiting, relying on queues or event buses. So what is this queue and event buses? We will discuss. But for now, you can consider these queues and event buses are nothing but your RabbitMQ and Kafka. So they will depend on them. Synchronous is simply but tightly coupled. Synchronous is simply and tight coupled means what? Can anybody tell me what is the meaning of this statement? See, if
As
synchronous communication is there, my order service calling the payment service. If payment service is down, can my application work?
no.
No. But in case of a asynchronous, if payment service is down, is this going to create any kind of a delay?
No.
No. Why? Because in case of a asynchronous some communication, we are not directly calling the right order service, not directly calling the notification service or product service. In that case, order service communicating with the RabbitMQ and Kafka. RabbitMQ and Kafka going to check whether the payment service is up or down, product service is up or down. If it is up, it can process the request. If it is down, it will wait till that service is up. Clear? So synchronous means it is tightly coupled. So if one service is down, other also going to be impacted. But in asynchronous, this is not available. Clear? So if someone asks you when to use which approach, synchronous means immediate. Asynchronous means when the service says, right, when the task can be handled by some background services. Clear?
Yes.
Right. Okay. So now with this right, we have understand there are two way of communication. One is synchronous, another one is asynchronous. Synchronous means we need to wait till the response is received. Asynchronous means the sender doesn't wait for the responses, right? And in synchronous, when to use when we need the immediate response. Asynchronous when we don't want the response immediately, right? Synchronous communication example is going to be REST API, gRPC. Asynchronous example is going to be RabbitMQ and Kafka. And layman example, phone call is the example of a synchronous. WhatsApp message is the example of a asynchronous. Technical example, when I'm placing the order, I need to check the product stock quantity. So that product stock quantity means we need to communicate with the product microservice. So that communication needs to be synchronous because we want the response immediately. Based on that, what we need to decide whether we need to place the order or not. Asynchronous example, notification service and the notification update the stock quantity. So these are the example of a asynchronous right communication. Now, so once we have this thing, next what we need to do? Clear, guys, or not? So if someone asks you what is inter-service communication, why we need inter-service communication, what are the different ways to communicate between services, what is the difference between synchronous and asynchronous, when to use synchronous and when to use asynchronous, can you give some layman example, can you give some real-time example, what the technology, right, what technical stack you can use to implement synchronous and asynchronous? If someone asks you this question, are you able to answer?
Yes.
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 Okay. Now what we need to do, we need to understand our core concept, that is RabbitMQ. So RabbitMQ, Kafka, gRPC, CQRS, all these things we are going to discuss. So let's start with the RabbitMQ. See, RabbitMQ means it is an open source message broker. So RabbitMQ is a open source message broker. So let me put it here, is an open source message broker. So also RabbitMQ is also called a messaging middleware. Okay, so let us try to understand from this one. So RabbitMQ is a message broker, also called a messaging middleware. So its core job is to receive, store, and forward messages between different parts of the system. So if you look at this example, so this is the producer, this is the consumer. Producer means you can consider one service. Consumer means another service. This consumer can be one or more. This consumer can be one or more. For example, order service. So order service is my producer. Consumer, so once the order is placed, we need to send some notification to the customer, to the admin, and to the vendor. So in that case, we are going to have a multiple consumer for that order placed right event. So in this case, what is the job of a producer? What is the job of this RabbitMQ? And what is the job of a consumer? First of all, you need to understand. So what is this RabbitMQ? It is the middleman between the producer and the consumer. Sir, what is the producer and the consumer? Producer is nothing but the service which is going to send a message. Sir, what is consumer? Consumer is the service who is going to receive the message or who is going to consume the message. Clear? So now, how it is going to be happening? So from the high level point of view, see, technically we are going to discuss what are the different components. First of all, you need to understand. Producer means he wants to send a message, but he doesn't know who are the recipient. So if you understand, this is loosely coupled. Loosely coupled means what? Means I am going to provide one message, but I'm not aware about who are the receiver of this message. Getting my point? So in this case, producer will send a message to this RabbitMQ. So if you take the example of your postal, so you want to send one letter to your friend. So in that case, you are having the letter that is going to be the message, and you are the producer. You provide that message to the post office. That post office is going to be your RabbitMQ, and the post office will deliver that message to the consumer at their convenient time. So now, in this case, the producer will create the message. Let assume the order placed. So order service is the producer. He created the order placed event, and that order placed event they are published to whom? They are published to RabbitMQ. So this RabbitMQ is nothing but it is a message broker. So what is the job of a message broker? So it safely holds the message. It will decide where it should go and wait until a consumer ready to pick it. So basically, once the producer publish a message to RabbitMQ, RabbitMQ temporarily hold that message. RabbitMQ will decide who is the consumer going to consume this message. RabbitMQ wait till a consumer is available to consume it. And this is the consumer. And the consumer, once he is ready, then he will take the message from the RabbitMQ. But the RabbitMQ also going to ensure this consumer is a valid consumer for this message or not. If he is not a valid consumer, he will not get this message. So once the consumer is a valid consumer, he will get the message from RabbitMQ. And once he gets the message, whatever he wants to do, he can do it. For example, he wants to send a notification to the customer. Okay, fine. So he will send the notification to the customer if he is the notification service. If it's a product service, then what he will do? Okay, I'm the product service, and this message what coming from this producer, right, to reduce the stock quantity. Okay, then I'm going to reduce the stock quantity. So basically, right, that is going to be the consumer part or the receiver part. Clear?
Yes.
See, okay. So why the name is given broker, right? For example, nowadays, if you are staying in a city and if you want to buy a home or you want to rent a home, so you are the person who is going to stay, right? And the owner is someone else. But between you and the owner, is there someone called a broker who is going to give you and who is going to show you the property where you want to stay or what you want to buy? So that person is nothing but he is the middleman. He is the broker who is doing or who is helping you what you want to achieve and what the owner wants to achieve. So in the same case, this is the message broker. Whatever the message you want to transfer, that message he will take the responsibility to transfer to the actual customer or actual consumer. So that is the name, right? This is the reason why he is behaving like a broker between the producer and consumer, and what information he is going to share, that message. So that is the reason why the name is given to this as message broker. Clear? Message broker, or you can say messaging middleware, or you can say middleman, whatever. Clear?
Captain, I have one question.
Yes.
What's the difference between then RabbitMQ and Delegate?
RabbitMQ.
Delegate.
See, that is a completely different story altogether. Delegate is doing the same thing, but in that case, whenever you are using delegate, the method what you are calling, right, that needs to be within your application, and that delegate is nothing but it's not a right what I can say server. So in this case, RabbitMQ is a server. Does the delegate have the capacity to hold the message for some time? Does the delegate having the capacity, right? What I can say to implement, right, to check and verify who is the consumer. I mean, delegate is similar to this one, but that is not robust. Delegate is basically what I can say, one way, right? So one way to call a method. So simply delegate and nothing but anonymous method, as simple as it is. So if you want to call that method, you need to call the delegate. And in case of a delegate, the producer should know the signature of the delegate and the producer will invoke the delegate. But in this case, see, this RabbitMQ is different than a delegate in the way, right? It can manage the data. Temporarily, it is going to hold the data. Delegate will take the responsibility to go, right? For example, right? For example, let assume you are going to have 1,000 requests per second. And now this RabbitMQ, you can create a multiple instances, right? One multiple instances in the sense load balancing environment. Load balancing environment means what? You have to remember this is a server. So what do we mean by server? Server means the way we are hosting our application into a server, creating an instance of that application. Similarly, whenever you are using RabbitMQ, RabbitMQ means it is a server. You want to host it, and this server can have multiple instances. They will receive the request from the producer, and then which instance is going to hold, that is going to be defined by the RabbitMQ. So delegate means it's an anonymous method. RabbitMQ means it is a server altogether, right? And the load balancing, storing the data, right, for temporarily, right, and again implementing the retry mechanism. So if the request is failed, okay, let me try again and again. So all these things are available with RabbitMQ, but that is not available with the delegate. Getting my point? So can you create a
Yes.
delegate as a server?
No.
No. Delegate means simply anonymous method. That's it. And if I want to invoke one method and I want that method should invoke that delegate, then in that case, I'm going with delegate. Delegate means anonymous method. Clear?
Yes, thank you.
Yeah. So now this is going to be server. And I'm going to show you how to download this server, how to host this server, how to configure this server, how this server looks like, right? I'm going to show you. So okay, so why a message broker is needed? See, in large system like e-commerce, banking, IoT, social media platform, multiple independent services work together. And direct communication, one service calling another service can sometimes cause some problem. What are the problem? If the receiver is down, if the receiver is slow, multiple receiver needs the same message, right? That is very difficult, right? For example, if the receiver is down, then what you will do? If the receiver is very slow, then what will happen? Like you will get response is very like let your response time is also going to very less, very high. So if the same message needs to be handled by multiple receiver, then what? Now, in that case, right, to overcome this, if your server is down, no issue. If the server is slow, no issue. My calling application is not going to be impacted. If if the message needs to be received by multiple server, no issue. My application is not going to be impacted. How? Now all these things are going to be managed by the RabbitMQ, right? So we need to send this message to RabbitMQ. RabbitMQ will decide, right, when to pass this message to whom, right? How and when this message will be circulated to the receiver, that will be taken care by RabbitMQ, right? How it works? See, in this case, there is a producer who will going to create the message. RabbitMQ, you can consider this is the post office, right? Or you can say this is the broker. Hold the message safely. So it will hold the message for some temporary purpose. It will decide where it should go and waits until a consumer is ready. So he will hold the message. He will decide who are the consumer and wait till the consumer consume the message. And the consumer is nothing but the receiver. They will pick up the message and process it. For example, once the right, notification service once the notification service is ready, they can send the notification. Once the product service is ready, they can update the product inventory. So that is so notification service is one receiver, product service is going to be one receiver, right? So these three things are going to be worked together, right? If you take the real-time example, you can consider RabbitMQ as the post office. Post office, right? Let's see how, right? It is the post office. So sender drops a letter, right? So producer produce the message. For example, you want to send a letter to your boyfriend. So if you go back to 1970, at that time, that letter functionality was there, post office functionality. Even today is also available. Some official documentation, right? Some important documentation, government document, they are also sending via post. So, but yes, that normal post functionality, I think, is only speed post functionality is available. Okay, that's fine. So you write a letter and hand it to the post office, right? Suppose you want to send a letter, so what you do? You write the letter and you say, hand this letter to the postman, or you can say in the post office. So in this case, if you take the technical example, that a producer application send a message to the RabbitMQ. So here you are the sender. Post office is the location, or you can say place where you hand over your letter to the post office. Similarly, if you take the real in technical, so we should have a producer application. Let's assume the order service, that is the producer application. They send a message, that is order placed message, to RabbitMQ. So these things is clear how this is related to our post office example,
Yes.
Yes.
right? Right now. So once you hand over the letter to the post office, or once you produce the message or send the message to RabbitMQ, then what the post office will do? So it will store the letter. So once you send the message, then that message is going to be the letter waits in the mailbox until the receiver collects it. So similarly, in technically, the RabbitMQ store the message in a queue until a consumer is available. For example, You hand over the letter to the post office will hold the letter, they will put inside your mailbox, right, which is available within your home gate, right? Similarly, RabbitMQ store the message in a queue until a consumer is available. So here the postman put that mail in the mailbox of the customer, which is available at the customer gate. Similarly, RabbitMQ also going to store the message where it will store. So in this case, this is mailbox, and in this case, this is a queue. So this mailbox, what available within the, right, what I can say customers, right, where the mail is available, where the letter is available. Similarly, RabbitMQ store the message in a queue. How long it is going to store the message? Until a consumer is available. So this point 2 is clear.
Yes.
So now, point receiver collects the letter, that is consumer process the message, right? Once you put the letter in the mailbox, then the receiver can pick the letter wherever convenient, whenever the receiver is free available, he will check and he will get the right letter, and after reading the letter, whatever he wants to respond, he can respond. Similarly, consumer fetch and process messages when they are ready. Right? So whenever the consumer is ready, they can fetch the message from the queue of, and they can process the message. The sender doesn't need to know whether the receiver is home, how fast they read the letter, or if multiple receiver exist. So they have no idea. So once you send the letter, right, then whether the receiver is at home, whether he is going to read my message, or read how many receivers are there to read my message, the sender have no idea. But the post office guarantee safe delivery. But what is the job of a post office? To deliver the right letter. So that is the job of a RabbitMQ in our example. Clear?
Yes.
Clear or not? Right. So now,
Yes.
why we use RabbitMQ? So basically, there are four important concepts that what you need to understand. What are the concepts? Decoupling, scalability, reliability, and asynchronous processing. So let us try to understand what do we mean by this. So decoupling. See, decoupling means what? Now, the producer and consumer services don't need to know about each other. So, as a producer, I'm not going to care who is the receiver. As a receiver, I'm not going to care who produces this message. So they are going to be independent. The producer send a message, forget about it. It doesn't care who process the message, when and how. Clear? Clear or not?
Yes. Yes.
Right. So if you take the traditional system, synchronous system, if service A needs service B, then A must know where exactly B is, whether B is online or whether B process the data. This creates tight coupling. What with the RabbitMQ, a producer only send a message to RabbitMQ. It doesn't care who read process it. I mean, who is the consumer processist, how many consumer exist, or even if they are temporarily offline. So basically, with the decoupling, the producer and the consumer, they do not know each other. Producer responsibility is to produce the message. Consumer responsibility is going to consume the message. Producer doesn't know who are the consumer, whether they are online, how many number of consumers are available. Similarly, consumer is going to simply read the message and process it, rather than thinking about who is the sender of this message. And this is possible because of the RabbitMQ, right? Suppose dropping a parcel in a courier box, right? In real time, you want to drop a parcel, so in a courier, you don't care, right? Who the delivery guy is, which route he will take. See, you want to right? Send a parcel in a courier, so you just put that message in a courier box. Now, once you put, are you going to check who is the delivery guy, which route he will take? Are you going to check this thing or not?
No.
No. So you just drop the parcel, let the system handle it. If you take the technical example, order service plays the order created message, right? You can say order service create the order created message, right? Order created message. Then the email service billing service, inventory service, all consume it without order service knowing or coordinating with them. Right. So once you place the order service, who are all consumer, they can consume the service, and order service is not aware about who are the consumer. So the decoupling means it's clear. Decoupling means the producer and consumer, they do not know each other. Producer responsibility to send the message, consumer responsibility to consume the message. Producer doesn't know who is the consumer, whether they are available, and rate or how many number of consumers are there. So he doesn't care about it. Clear?
Yes.
Right. The
Pranay,
second benefit is scalability.
I
Right?
have
The
one
scalability.
question.
Yes,
The
please.
RabbitMQ, it works on queue system, right? The queue is work
I
like
will
a
discuss. I
people
will
system.
discuss. I will discuss what is this queue, what are the different components, how that queue
Okay,
is being populated. I will show you. Right.
okay,
So
thank
we are just going. That is the reason why I have not given right more. What I can say, uh, priority to this queue. Queue means first in, first out. Right.
Yes.
So there are different algorithms are available, and what algorithm RabbitMQ is uses queue. So which you will come first, that will be consumed first. So we'll show you that practically. So don't worry.
Okay.
So scalability will come now. Scalability means RabbitMQ enable us to add more consumers, workers to handle increased load without modifying the producer logic. Right? For example, as demand grows, right? For example, now your application now that RabbitMQ, you develop the RabbitMQ server, and now the sender sending 1,000 messages per minute, and your and RabbitMQ server easily handle that 1,000 requests per second per minute. Now what happened? Now that number of requests increases from thousands to 1 million. So from 1,000 to the number of requests increase to 1 million. So if it increased to 1 million, a single RabbitMQ cannot handle that logic. A single RabbitMQ instance cannot handle that logic. So what we need to do, we can we can increase the number of instances. So instead of a single RabbitMQ instance, we can create multiple instances, and that load is going to be distributed equally. So that is possible with RabbitMQ. So RabbitMQ now can process multiple requests at a time. If you take the example, imagine a call center. So more calls coming in. So if more calls coming in, then what you need to do? You need to add more agent or not? Yes or no?
Yes.
Yes.
Right? So more agent you need to add. So that if you are not adding more agent, then what will happen? And then more time it will take to resolve the issue. So the caller, the producer doesn't know how many agents are available. They just leave a request. So in that case, what will happen? Now in that case, the producer simply going to produce the message. Does the producer going to know how many instances are available? Not required. So that is the responsibility of the RabbitMQ. Clear? So basically, if your number of requests are increased, so you can increase, right, the number of instances so that more requests they can process to simultaneously, right? So this is scalability, reliability. So RabbitMQ ensure no data loss by persisting message in queues, even if the consumer is offline or crashed. For example, what it means? It means once you publish one message, once you send a message to the RabbitMQ is going to store that message temporarily. I mean, persisting means storing that message. And then it will store that message as long as the consumer is available and consume. If the consumer is offline, no issue. I'm storing that message. Once the consumer becomes online, then he can consume the message. While consuming the message, if the consumer crashed, no issue. Still, I'm holding the message as long as I'm not getting any acknowledgement from the consumer that he processed the right message. I cannot delete that message from the queue. So what exactly, or sometimes what happen while handling, there is some issue. So that retry functionality is also available. So basically, as it is storing the data, so there is a very minimal chance of a data loss, even if the consumer is offline or even if the consumer is right class. So if you take the real-time example, a voicemail system, even if your phone is switched off, messages are stored until you are back online to listen. For example, some of your friends send a message to you, whether it is a voice message or a text message or whatever it may be. If you switch off the phone, no issue. But when you switch on the phone, then you are getting that message on your phone number or not. Yes or no?
Yes, we
That
get.
Yes.
message is lost. No, that message is not lost. Yes, you are not operate your phone is switch off, so you are not getting that message. But when you switch on, definitely you will get that message. Why? Because that message is stored right, stored in the RabbitMQ. Until and unless you have not received that message is saved. Clear?
Yes.
Yes.
Right. And finally, asynchronous processing. So we have already discussed that is the reason why, because of this asynchronous processing, we are using message broker. RabbitMQ support asynchronous message handling, which means tasks, right? Asynchronous processing means what? The task that take time can be done in the background. So asynchronous means we need to call that service and wait till the right service response. But in this case, we can handle that in the backend, right? Background. So, and we have already discussed what is synchronous and asynchronous, and with RabbitMQ you can achieve this asynchronous processing. Asynchronous processing means that processing is going to be happen behind the scene using some background services. Clear?
Yes.
Okay. Now we need to understand the key concept or key components of RabbitMQ. So whenever you are developing or whenever you are going to work with RabbitMQ, you need to understand what is the producer, QE, binding, exchange, consumer, and routing key. So these six components all together give the architecture of RabbitMQ. So if you want to understand RabbitMQ, then you need to understand these six components. So what is the producer, what is the consumer, what is exchange queue, binding, and routing key? These components, six components. Let us proceed and try to understand. So we have already discussed what is producer. Producer means what? Now it is part of your system. Technically, it is a microservice responsible for creating and sending message to RabbitMQ. Clear? So producer means he will send the message to the RabbitMQ. Clear?
Yes.
Clear?
Yes.
Producer means who will create and send a message to RabbitMQ. Right? So if you take the example of your post office, right? Think of the producer as the person writing and posting a letter. You don't deliver the letter directly to the recipient. You hand it to the post office first, right? Producer doesn't need to know who will read the message and where. It simply drop it into the RabbitMQ. Its responsibility ends once the message is handed over to the RabbitMQ. So once as a producer, you handed the message to the RabbitMQ, your job is done. It doesn't care who will consume and the message and when, right? For example, if you take the example of an e-commerce system, when a customer places an order, the order service is going to be the producer, send a message like order created to RabbitMQ. Clear? Clear or not? The RabbitMQ ensure the message gets to the right consumer. So then it is the responsibility of the RabbitMQ to decide who is going to read the message. So producer means it main responsibility create and send the message to RabbitMQ. Once the message is handed over to RabbitMQ, its job is done. He is not going to think about who are the consumer, when they consume, whether they consume. This is not the job of the producer. Clear?
Yes.
Clear? Then what is consumer? A consumer is part of the system also. Again, this system means it can be a microservice or application that receive and process the message from where it will receive and process the message from the producer or from the RabbitMQ.
From the RabbitMQ.
Rabbit.
So it picks up the message and does something useful with it. So whatever, once it receives the order placed event, then if it is a notification service, he know what to do. If it is a product service, he know what it needs to do. If it is a notification service, then he will send a notification. If it is a product service, then he will reduce the product stock quantity. And all these things are going to be done asynchronously. So asynchronously means using some background task or behind the scene, which doesn't bother about the production. Clear?
Sorry, Panay, can you please come again?
Which one?
The same thing, like the when any consumer uh,
See, first of all,
decrease
you
the
just tell me. So first of all, you just tell me, producer, as a producer send a message to who?
to consumer
How?
to
So
to
that
to to RabbitMQ to RabbitMQ
then consumer will receive the message from whom?
RabbitMQ.
So once the consumer receives the message from RabbitMQ, then what the consumer is going to do? For example, one order placed message, right? It received, right? The inventory service, or you can say the product service, receives the order placed message from RabbitMQ. So once the inventory service or product service receives the order placed message, then what he needs to do?
Oh, okay. He will decrease its product.
Product stuff. If the same message received by the notification service, then what the notification service needs to do?
Yeah. It will send the notifications to the
Clear?
consumer.
So from where the consumer will receive the message? From RabbitMQ. Once
Rabbit.
he receives the message, what he needs to do? Based on the message, what he received. If the
Yeah.
message is order placed, I need to send order placed. If
Yeah.
this is the order placed message, right message, that's the notification going to send the payment invoice? No, order placed means order placed in notification we need to send. Clear?
Yeah. Thanks.
Okay. So now, what is this queuing? So as I mentioned, the RabbitMQ is going to store the message temporarily. It is going to store the message within the RabbitMQ is going to store the message until they are delivered to the consumer. Right? Until and unless this consumer didn't receive the message and process the message, that message is going to be stay in which going to stay where? It will be going to stay within the RabbitMQ. Within the RabbitMQ, there is a component called a queue, or you can say this is the buffer area where the message is going to be stay temporarily, not permanently, temporarily. Why I'm saying temporarily? Because once the message is consumed by the consumer, that buffer area is going to be removed. Clear? So what is queue? A queue is a temporary buffer inside RabbitMQ where messages are stored until they are delivered to the consumer. Clear?
Yes.
Right. So you can think a queue like the mailbox in front of your house. The post office put letter inside and you pick them up when you are convenient, right? As per your convenient time, when you are available, then you will pick the letter from the mailbox. Similarly, RabbitMQ, right? Once it receives the message from the, right, what I can say, producer, he will put that message. Where it will put that message? It will put that message inside a queue. Clear? Clear or not?
Yes.
Right? So what is queue and what is RabbitMQ? RabbitMQ is the server, and RabbitMQ is going to be composed of a multiple component. And one such component is queue. What is the job of a queue? Now, once the RabbitMQ receives the message from the producer, that message he will store temporarily within the queue, and that message will be available within the queue until and unless they are delivered to the consumer. Once the consumer receives the message and process the message, then that message is going to be deleted from the queue. How it is going to be done? Now, it is going to be done in the order of a FIFO. What do you mean by FIFO? First in, first out. So how that FIFO principle is working, and I hope you all guys know. There are two approaches, one is LIFO and one is FIFO. Last in, first out is LIFO. In this case, first in, first out. So whichever come first, that will become in the top position, and then that message needs to be read, and accordingly he will process, right? So once the message is read and consumed, that is going to be deleted from the queue. Clear?
Yes.
Yes.
Right. And within a single queue, a message is delivered to only one consumer. This is very, very important. For example, how many queues are there? you can have a multiple queues. One queue is for order queue. And right, for example, if you are sending that message, right? What message you are sending? If you are sending order placed message. Order placed message means if you are having three different consumer. One consumer, let assume the product service. Another consumer, let assume the notification service. Another consumer, let assume the assume the let assume some admin
Payments.
service, or you can say vendor service, right? So in that case, for each service, you need to create separate queue. One queue for notification service, one queue for the payment, right, admin or vendor service, one queue for the product service. And that message, once you received from the consumer, sorry, from the producer, this RabbitMQ responsibility is to put that message in all the different queues, right? So it will put the message in the queue which is designed for notification, queue for the product, and so on. But the question is, how he will decide where the message needs to be put, whether the message needs to be put. See, in our application, we have 100 queues. So out of this 100 queues, let assume 3 queues or 4 queues are there. Suppose, let assume we are going to have 5 services. So 5 queue we created, one queue for each service. Then once the message is received by RabbitMQ, for example, order place. So once the order place message is received, this order place message is not going to deal with my user microservice. It is not going to deal with my payment microservice. It is going to deal with the notification microservice. It is going to deal with the product microservice. Then how the RabbitMQ will decide in which queue I need to put this message? Are you getting my question? Queue is fine, where we are going to store the message. But how you will decide? How this RabbitMQ decide in which queue I need to put this message? For that purpose, it is going to make use of exchange. Clear? So producer is clear, queue is clear, consumer is clear. Producer will send the message. Consumer will consume the message. Queue means it is going to store the message until it is consumed by the consumer. Now, to store the message which is sent by the producer to the queue, it is going to make use of a exchange. Right? So let us try to understand what is exchange. So exchange is nothing but you can consider it is the traffic controller in RabbitMQ. So what is exchange? It is the traffic controller in the RabbitMQ. Sir, what do you mean by traffic controller? Traffic controller as the control, right, how the people are going to be right travel. So in the same manner, once the request received, once the RabbitMQ receives the message from the right, what I can say, producer, he will guide, right? He will decide, this exchange will decide in which queue I need to put the message. Getting my point? So this exchange is a component within the RabbitMQ. The role and responsibility of this component to decide in which queue the message needs to be stored. Clear?
Yes.
Right? So basically, what is the job of a queue? The job of a queue is to decide the job of a exchange is to decide in which queue the message should go. And again, guys, remember this decision, right? If you want to take some decision, for example, if you take the example of a ASP.NET Core WebAPI or MVC application, when you send a request, then that request is navigated to some of the action method within some of the controller. Yes or no?
Yes.
How that decision is made, who take that decision? That routing engine. So you have defined some route, and based on the input parameter, based on the method name, based on the controller name, right, the routing engine going to take the decision who is the controller going to handle that request. Similarly, this exchange is going to decide who right, to which queue the message needs to be put. But how he will decide? So he will decide by using two key right concept. One is bounding, another one is routing keys. So one is bounding, another one is routing key. So using this binding and routing key, he will decide in which queue the message needs to be put. So what is binding and routing key, we'll see in some time, right? For now, just remember binding means some rules that what we need to define. Routing key means what? Some input parameter. For example, whenever you send one letter, then that letter is going to contain some address of the receiver or not. So if there is no address, then to whom he will deliver the letter? The postman will deliver the letter to whom if there is no addresses. Similarly, whenever the producer produces a message, at that time, he is going to provide some information address. And that information we can consider here as routing keys. So these routing keys are nothing but labels attached to messages by producer. Routing keys are nothing but labels attached to messages by producer. So for example, you can see within your controller, you can have what I can say, two action method with the same name but with a different parameter. So if you are having one controller with two action method, you can have two action method with the same name but with a different parameter. When at runtime, based on the route data, whatever the data sent by the client, based on that data, the routing engine will decide which version of the action method will handle that request. Similarly, so whenever the producer send one message, that message is going to be attached to with some label. This label is nothing but routing keys, and this routing keys are nothing but you can say header, custom header, key value pair. So based on this key value pair, the exchange will decide in which queue we need to put this message. See, guys, remember, understanding this concept technically is very, very difficult. But once we develop the application, once we create the exchange, once we create the right some services which is going to consume. So practically, once we see the example, you will get more clarity. For time being, just remember what is the job of an exchange. Exchange is going to decide in which key the message should go. Clear? And for taking this decision, that exchange is going to use two things. What are the things? Binding, that is the rules and regulations, and routing key. The routing keys are nothing but labels attached to the message by the producer. Clear? And guys, remember, this is the traffic controller. Traffic controller means what? He is not going to store the message. The exchange is not going to store the message. It is only job is to route the message to appropriate queue. Clear?
Yes.
Yes.
Right. Again, so there are four type of exchanges. There are four type of exchanges. What are the exchanges? You can see direct exchange, fan out exchange, topic exchange, and the headers exchange. See all this. See, guys, remember this exchange, this queue, these things, whatever I'm showing. These are available within the RabbitMQ right application website. Once we open the RabbitMQ server, I will show you all these things. So now this exchange means what? Direct exchange. So whenever I'm creating this direct exchange means what? Direct exchange means matches the queue that matches the routing key exactly. So basically, whenever you send a request, that request is going to contain some routing key. So based on the routing key, he will decide, based on the routing key, he will decide which key to be used. For example, if I'm having if the message is composed up with this routing key, suppose you send this routing key, payment.success, then the queue which is bound to payment success will receive the message. Clear? Suppose you created a queue and that queue is bound with this payment success. Right? If the queue is bound with this payment success key, and whenever whenever the RabbitMQ receives the message, and if that message is bound with this key, then the exchange will direct that message to the queue which is bounded with payment success. Clear?
Yes.
Right? So here you have to remember two things. One is queue which you need to create it. And while you are creating the queue, you need to provide the rules and regulation that this queue is bound to the messages which is going to contain the key, routing key payment success. And whenever the sender send a message, if that message contains this key payment success, then this exchange will route that message to payment success queue. Clear? I mean the queue which is bound with payment success. If multiple queues are bound with this key, then what will happen? Then multiple queue will receive the same message. Clear? Clear or not?
Yes.
Right? Then what is this fan out exchange? Suppose fan out exchange means what? It will route the queue to all. It will route the message to all the queues. So in this case, it is going to ignore the routing key. It is going to ignore the rules and regulation. Nothing is going to be checked. In this case, how many number of queues are there? All the queues is going to receive the message if it is fan out. Here, fan out means simply ignoring the routing key. The message will be sent to all the queues, right? All the queues which are bound with this fan out exchange. Clear?
Yes.
Yes.
Okay. So topic exchange means pattern matching. Pattern matching means what? Now, for example, you created a bar queue with this right rules and regulation. User dot star dot activity. So user dot star, and here you created order dot hash. So what exactly it means? You created a queue which is bound with this binding or rules and regulation. Another queue is bound with this binding. So what exactly it means? It means matches, right? User.login.activity, user.logout.activity. So here star is going to represent a word. And here hash means any number of matches, order.created, order.updated.payment. So basically, these are some of the rules and regulations which are bind with the queue. And whenever the request comes, and if the request matches with this key, then that will be also validated. So here, exact key name. So here, order.created means payment success means the key exact match. So here, direct exchange means exact match. If the key name is changed, you will not consider. Here it will ignore the right routing key. Here it will use the pattern matching. Pattern means what? For example, right payment success. Suppose you created another queue. Suppose you created here payment dot right payment dot hash. So then what exactly? Payment success, right? Payment held, etc. See, in this case, the payment success. This is the exact key that what you need to match so that it will bound to the key. If a queue is bound with this payment data hash means what? Payment success, payment failed, right? They are all going to be stored in the same right within this queue. So here you have to remember direct exchange means exact key name. There is no pattern matching. Cannot means it will ignore the key. It will store the message in all the right queues. Topic exchange means it will make use of a pattern matching. So based on the pattern, it will match. And header exchange means based on the header. For example, ignore the routing keys completely. Use a header. So header means you need to send some message like in the header format PDF, format type report, right? So if the queue is bound to the header, and if the header is this one and you send this header, then it will be mapped. So again, guys, remember these things, it will take little time to understand. Why? Because this is going to be your technical aspect. Technical aspect in the sense, practically I'm going to show you how to create this fan out topic exchange, how to create a queue, how to create a queue with some pattern, how to create a queue with fan out, how to create a queue with header. All these things I'm going to show you practically. But for now, just remember, so exchange means it is the traffic controller which will decide to which key the message should go on. And again, there are four type of exchanges. Direct exchange means exact the key name. Fan out exchange means ignore the key name. Directly, right, it will pass the message to all the queues. Then topic exchange means it is based on the pattern matching. Header exchange means key is ignored based on the incoming header. it will decide to which queue the message should go on. Clear?
Yes.
Right. So binding means, as I have told you, so exchange will make use of two things. One is binding, another one is routing key. So this routing keys are nothing but label attached to message by the producer, like this one. So key is this one, right? Some key you need to pass. So key is user dot activity. So I mean key is going to be user dot login dot activity. So that what we need to decide now. What is binding? Binding is the rule that connect and extends to a queue. So binding is the rule that connects and extends to a queue. It tells the exchange if a message comes with a certain routing key and put it in this case. So basically, this bounding means it is going to provide the rules and regulation right for the. So basically, so as we have discussed, right, right when the message is sent, right? If the address is finance department, then what exactly it means? In the finance department mailbox. If the message, whatever we send is urgent notice, then put copy on all the departments. So basically, right, if you take the example, so exchange, whenever I'm going to create, right, some keyword. So it is going to be something like this: exchange, direct exchange, queue, invoice queue, binding, routing key is going to be this one. So these things we need to put while creating the right queue, right, within the what I can say RabbitMQ. So it means only message with the writing key invoice generated will be delivered to invoice queue. So how it is, how these things is decided? See, what is the type of exchange? Guys, tell me, what is the type of exchange? Direct exchange. Direct exchange means what? Means the direct exchange means it is going to check the pattern or the exact name.
Exact name.
Exact name. So in this case, right, exact name is what? Exact name is what?
Invoice generated. Invoice dot generated.
And here we have done the settings. So what settings we have done? Exchange is direct exchange, queue is invoice queue, binding, routing key is going to be invoice generated. So what exactly it means? If I created one right instance within the RabbitMQ with this all these informations, what exactly it means? It means whenever a message comes, if the message only message with the routing key invoice generated will be delivered to this invoice queue. Why? Because it is using the exchange direct exchange. Clear? This point is clear?
Yes.
Yeah. Clear or not?
Yes.
Right? So if these things we decide means what? Only messages with the routing key invoice generated. Instead of in the direct exchange, right? If I go with the this topic exchange, then what will happen? For example, if I go with the instead of a direct exchange, it is going to be the topic exchange. Then what will happen? Now, in case of a topic exchange means what I need to do? Invoice dot star. So in this case, only message within the invoice dot generated, invoice dot star. Star means it can be anything will be delivered to this invoice queue. Clear? Routing key invoice dot star. Star means read complete word will be delivered to invoice queue in with this format. Is that clear?
Yes, sir.
Okay. So basically, these three things you need to understand. So what are the things?
And
What is the
Panay,
extent? Yes.
what will be the hash if invoice dot hash?
Okay. So if I'm using invoice dot hash means what? Any number of words. Say invoice dot payment dot success, invoice dot order dot failed. Right? If I'm using a star means a single word. Clear?
Okay.
Star means single word. Invoice means any number of word. Clear?
Okay.
Right? Star means exactly one word. Hash means zero or more words. Clear?
Okay.
Right? And routing key we have already discussed. This is a string attached to the message by the producer. So different types of messages we have discussed: direct message, fan out message, topic message, header message. So how the message flow, let us try to understand. So this is very, very important. So as we have already discussed, so the producer will send a message. So see, this is the producer and the rest of the things what you have seen here, this is going to be my RabbitMQ. So the producer will send a message. That message will be handled by whom?
Exchange.
Exchange. And if the exchange it is using right topic exchange, or it can be your right what I can say different type of exchanges are there, and this exchange will decide the binding. Binding means the rules and the regulations. So order dot star, order dot created, order dot hatch. So three bindings are there. Order dot star means it will put that message. Let assume right this is the bindings, rules and regulation for this topic exchange. So for this exchange, topic exchange, we have decided. So there are how many exchanges are there? Four exchanges are going to be there. One is topic header, another one is pattern matching, another one is right, different four
Data.
exchanges are there, right? So based on the rules and regulations, what we decide, and based on the exchange type, so once the message is sent by the producer, that message is going to be stored in different queues. So let assume we are having billing queue, inventory queue, and analytics queue. Three queues are there. And the same message in this case, and here you can see we have decided these rules: order dot star, order dot created, order dot hatch. And then whenever the order service plays one message, and let assume all these three queues provided some kind of rules and regulations, and these three rules and regulations satisfy the message what is sent by the producer service. So if all these three rules and regulations are satisfied, then what this exchange is going to do is he will put that message in all these three queues. Clear? So producer send a single message. Here exchange is taking checking the rules and regulations. As per the rules and regulations, this message is satisfied by three different queues. As this message is satisfied by three different queues, so that message is going to be stored in three different services. Three different queues. All the queues will receive this message. So once the message is received by the queue, then billing queue means what? That is going to be deal with the billing service. So billing service will consume from billing queue. Product service will consume from the inventory queue. Analytics service, if any whatever the service, right, the respective service is coming into the picture, and they are going to consume the message from the respective queue. So this is how the message is flow with RabbitMQ. So you send the message, right? You send the message to Exchange. Exchange will make use of this binding, all or you can say rules and regulations to decide where it needs to put the message. I mean, in which queue. Once the message is put by the queue, then this billing service is nothing but your consumer. You will consume the message from the service. Inventory will consume the message from the service. Analytics service is the consumer who will consume the service from this analytics queue. So this is how it will work. So how now producer send a message to exchange. Exchange will make use of routing key and binding to decide in which queue the message should be goes to. And once the message is put in the queue, then it is the consumer going to consume the message. Clear?
Sir, I have one doubt.
Yes.
How this queue will be created?
I will show you this thing practically. Why you are in a hurry?
Okay.
So I'm just showing this theoretically. So if whatever I'm showing theoretically, I'm going to show you all this thing practically. Clear? Because that is the practical, that practical things are there. I will show you all these things practically. Clear?
Pranay, I have one
Good.
question.
Yes.
In above scenario, the exchange, we have decided that the if the message is order dot created, so
See,
what
if the order that created, if the producer send the key order, key equals to order created, then all these things will be satisfied. Na? So order dot star, star means that will be replaced with a single word created. Order created, that is fine. Order dot has means it is a single word, right? It can be
yeah, yeah,
zero or more number of words. That
more
is
number
also
of
that is also say zero or more. So if you are passing order dot created, then that is also if the producer send a message order dot created, I mean the key, then all these three will be satisfied.
Yes. So, mainly, basically, I have a question that that order dot created, the exchange is creating all that rule.
Yes.
Okay.
So exchange will check the rules and regulation. And all these three rules, whatever we define, all these three rules will be satisfied by the message what the producer is saying, yes or no.
Yeah. So all
So,
these three rules are created in the exchange that we are saying.
so this is, see, exchange is different and these rules are different. Binding is different. Binding will create these rules. And
Okay.
when the producer sends the message, then the exchange will take the message, exchange will check the binding, and as per the binding means rules and regulation, and as per the message, whatever is sent by the producer, the exchange will decide to which queue the message needs to be sent. So
Okay.
exchange
Okay.
will receive the message, exchange will use the binding to decide where to put the message.
Okay.
So
Sorry to
in your
interrupt you, sir.
application, you will create exchange separately, you will create binding separately, and you will create the queues also separately. All these things we are going to discuss technically.
Okay.
Sir, I have a one doubt here in the
Yes.
diagram. Means like, as I understand that, means producer will send the request to the exchange. Okay.
Yes.
So, but
Yes.
producer will decide, I think, which queue and the which rules will be applying, or is which queue it
No,
will be
no, no.
going.
Producer
Exchange
has
will
no
not.
idea.
Yeah.
Producer have no idea related to the queue. Producer have no idea related to the consumer. Producer can only pass a routing key. That's it. Which key to
Okay.
be passed on, that will be the responsibility of the RabbitMQ.
Then which
Producer,
flow it will goes, who will decide?
so that exchange will decide, na.
No, suppose I have a payment gateway. So I definitely want to be this flow to be a direct to the specific consumer. So so exchange will decide how the exchange will decide. Means I think
That rules and regulation you need to provide, na. If the request is coming payment dot star, then that message needs to be put inside the payment queue. So that logic you need to define within the RabbitMQ.
okay. Oh, I got it. Means rules rules we need to attach on that routing.
You see, nothing is going to happen automatically. We need to
Ah,
provide the
means
rules and regulation within the RabbitMQ. We need to create the queue. We need to associate the queue with bindings, and then the exchange once the receives the message, he will use the binding to decide in which queue we need to put the message. That things we need to define.
okay. I understand, sir.
Yeah.
Sir, I have
So
one question, sir.
Yes.
So, if the consumer is read from the queue, so that message will be removed from the queue, sir?
Yes. See, if you know the working principle of a people, what do you mean by people?
First in, first out, right?
So once you read one message, right, then one element from the queue, that is going to be removed or it will be stay for there for a longer time. For example, in a ticket counter, so the person who is sit in the first position, stand in the first position, once he receives some ticket, he will be stay there or he will be removed from the queue.
Yeah, it will be removed. But my another question is, so if that is removed, so while processing at the consumer side, if we get any exception, in that case, how
Exactly,
we can
exactly,
get the
exactly. So what I am saying that in that case, once the consumer consumes the message, he will send one acknowledgement. I consume this message. Once the acknowledgement is received by the queue, then that message is going to be removed.
okay. Okay,
Yes,
so all these things we need to set at the queue level for that
yes,
acknowledgement to get.
yes.
Okay,
All these things will be said.
okay,
So now,
okay.
whenever you are attending the interview question, will get this right. Interview will get what is RabbitMQ, how does it work? What are the different type of exchanges, direct to fan out topic header? How does RabbitMQ help achieving scalability in microservices? You can create multiple instances, load balancing is there. What happens if a consumer crashes while processing a message? What you asked right now. So RabbitMQ wait for a acknowledgement from the consumer. If the acknowledgement is not received, then you will write again that message is going to be in the requeue, right? So that it can be processed. Requeue means it will not be stay in the top position. Again, it will become behind the scene, so that it can be picked again later. What is the role of routing key? So this routing key is going to decide how the message is going to be right extends, right? I mean the routing key is the identifier attached to a message by the producer, and the exchange uses is to decide which key should be used to receive the message. And then how do dead letter queue work in RabbitMQ? See, this is a concept. You might get this question, right? What do you mean by DLQ? So it is a special queue where messages are sent when they cannot be processed. For example, after many failed attempts, after many retries, right? If there is no consumer to consume the message, I cannot put that message for a longer period of time in the queue. But I need to provide some extra time. After that time, that message needs to be moved from the queue to this dead letter queue. Dead letter means dead queue. Dead queue means these are the message which is not consumed by the consumer, and then you can verify why it is not sent, and that what functionality you need to handle manually. Manual means if the email ID is wrong, if the mobile number is not wrong, then in that case it cannot send messages. Again, if the service is down, right, whatever the URL you provided for the consumer, or if the consumer service is down for 1 day, 2 day, right, I cannot put that message in the queue for 1 hour or 1 day or 2 day. So in that case, I can move that message to right a dead letter queue, so that you can check and all this thing. So how do you ensure durability exactly? Uh, who is on mute? Rajat, please mute yourself. Right? How do you ensure durability? See, durability means right. If how you will ensure there is no data loss. For example, mark the queue as durable, so it survived broker restart. So broker restart means if you see this message broker means it is a service. If you restart the service, then it's still going to store the queue data, whatever it is there. Persistent messages means what? Mark each message are persistent, so it is written to the disk. So whatever the message, they are going to be stored in the disk, so that if you restart the server, then also the messages are available. Publisher confirm means what? Acknowledgement, enable acknowledgement. For example, what it means, once the consumer consumes the message, he will send an acknowledgement to the RabbitMQ, so that RabbitMQ will ensure that this message is read by the consumer. So together these things ensure right durability, right? Right. See, guys, again, I'm saying don't put any message in the chat window. Anyone having any question, unmute yourself and ask me, because I'm not going to check the chat window again and again. So, can RabbitMQ deliver the same message to multiple consumer? Yes. So, what you need to do? You have two options. One is fan out. Fan out means what? Like it will ignore the binding rules and regulations. It will put that message in all the queues. And second, you have to create a multiple queue which are bound with the same routing key. These are the two options that what you can use to send the message to multiple consumers. Clear?
Sir, I have one doubt regarding these queues. Okay, so do we need to create it manually or
Manual
programmatically?
means, see, they have provided these things. So I will show you this thing practically. And so why you are in a hurry? How to create the queue? How to use this queue in our application? All these things are there, and that is the reason why from the beginning I have told you I will take 3 sessions to make you understand this RabbitMQ concept. It is not that easy. So theoretically it's fine. I'll show you also this thing how to do things within the right RabbitMQ server. And then I'm also going to show you how you can use this thing within your .NET Core application. So all these things I'm going to discuss. So this is the
Sir,
introduction part. Yes.
sir, we have to define the maximum try attempts with the queue, or is it by default?
So the default option is there. Manual setting is also available. So all these things are possible. So you can do it whatever way you like. Default option available. Manually you can also set now. So the last thing what we are going to discuss in today's session, how to download, install and RabbitMQ locally on a Windows operating system. So basically now what we are going to discuss, how we can download the RabbitMQ on our Windows operating system. Why I'm using Windows operating system? Because I'm having only Windows operating system. If you are having Linux and other, you can also do the same settings there, right? So to set up RabbitMQ locally, what we need to do, we need to install two software. What is Erlang OTP and what is RabbitMQ SQL Server. Sir, we are going to
No.
Yes, we lost it.
enable, guys.
We missed it like 1 to 2
No,
minutes.
actually, power off. Wi-Fi connection down, so I just connected from my mobile network. Now I'm audible.
Yes, yes.
Yes,
Yeah.
yes.
Yes.
Okay. So guys, remember, whenever you are going to use RabbitMQ, so you have to install this Erlang OTP. Sir, why I'm going to install RabbitMQ, then why I need Erlang OTP? For example, you just tell me. So whenever you want to develop the .NET application, you need .NET runtime or not to run the application?
Yes.
Without installing .NET runtime, can you run the application?
No.
So similarly, this RabbitMQ, it is a server, and for running this server, this Erlang OTP is the runtime environment. So you have to install this Erlang OTP, and once you install this OTP, then you need to install this RabbitMQ server. And this RabbitMQ server is going to run on this environment. So let us proceed and see how we can install this thing, right? Let us proceed and understand. Guys, remember, okay, so Erlang, so two software you need to install, that what we have discussed, Erlang OTT. It is the programming language using which that RabbitMQ is developed. So that for to run that application, we need this Erlang environment. Similarly, .NET application, .NET runtime for Java application, Java runtime. Similarly, this is the runtime for our RabbitMQ application. So first of all, we need to install Erlang before installing RabbitMQ, and you need to install a version that is compatible with your RabbitMQ version. So mostly what you can do is Erlang OTP 20.6.7 or Erlang OTP 227.7 you can install. Latest one is Erlang 28, but this Erlang 28 is not supported for RabbitMQ. So you can install either this or this version, but you should not install the latest one. So if you want to check which version to be installed, so I have provided the link. Just open this link. Erlang version requirement supported versions, right? Erlang 28 support. So here it clearly mentioned Erlang 28 has significant changes around employee and is not currently supported by RabbitMQ. So RabbitMQ doesn't support Erlang 28.7. So you cannot use earlier version, right? Anyone 26.7, 27. So you can use RabbitMQ. This is the server, message broker server. And you can install this using multiple options using the exe installer. This is the recommended approach for beginner. You can use Doco or you can include some G file. But for a beginner, as per the starting point, it is recommended to use this official exe installer. So let us proceed and install this thing. So I have already installed this on my machine. So I will show you the step and the process. So you have to go to this one. So currently you can see by default which version is selected and which option is showing it is Erlang OTP 28.0.3. Is this version going to support RabbitMQ? No.
No.
So which version I need to select? I need to select any version 27. Let's assume I'm going with this one. So now it is selecting this one. So now I don't want this one. I want OTP, right? OTP 26. You can select this one. So that is what I have provided. So I'm going with this 26.2.5.40. You can go with this 27 also, that is also fine. So 26, 27, these two are supported. So anyone you can use, right? So once you select, then you need to click on this download Windows installer option. So here you can see download Windows installer. Once you click download, it will download and you will see this one. So here you can see This OTP 26, it is not supported. This is the OTP. All right, this is the exe file it will download. Clear how to download the Erlang OTP? Is that clear?
Yes.
So once you download, then you need to follow the on-screen steps. So very simple. What are the steps? So first of all, you need to choose the component. So all the component you need to select. Then choose the location, default location. You can go with the default location. See program files, Erlang OTP. Choose the start menu. Right from this screen, just click on the install button. Accept the license. If this visual Microsoft Visual C++, this is required by Erlang OTP. If this is already installed, that is fine. If not installed, you can also install that. Just accept the license and install it. Once the installation completed, you will get this message. So once this is done, then what you need to do? You need to add Erlang bin folder to the system path. So basically what you need to do, wherever the Erlang is installed within your system, go to the bin folder and put that bin folder right into the system path, right? For example, if you look at my bin folder for this one is this one. See, program files, Erlang OTP dot this one. So I just go to this directory. So this is my program files, Erlang OTP bin. So this is the bin folder path, and this path I need to add into the system path. So how you can do this thing? Right. So open the run window. SYSDM system admin. Right. SYSDM. Just click sysdm.cpl. The right command I have provided here, sysdm.cpl, and press enter. So once you press enter, go to the advanced tab, and in the advanced tab, you will find this environment variable. So click on this environment variable. Within this environment variable, right, go to this system variable, and within the system variable, click on right path. So here you can see this is my path. So within this path, first of all, right, we need to add this. So within this path, what I need to do? I need to add this path. So how I can do this thing? So once you select the path, click on this edit button. So once you click on the edit button, it will show whatever all paths are being added. So now check whether C Erlang OTP is installed or not. So here you can say C program files Erlang OTP.bin. This is installed. So if this is installed, why? Right, I have already installed. If you have not installed, suppose I delete this. So now this is not available. So what you need to do? Just click on this new button and provide this one. And then click on this click OK, OK, and OK. Clear? Now, if you verify, right, then you will see that Erlang OTP should be there. So advanced, environment variable, path, edit. So now Erlang OTP is there? Yes or no?
Yes.
Yes.
Right. So that path you need to add. So that path you need to add. Once you add the path, then you can verify whether Erlang OTP is installed or not. How you can do this thing? Just OK, OK. Open the command prompt. Okay, OK, the command prompt. CMD ERL. See, Erlang OTP 26 is installed on your machine. So if it is installed successfully, you will get this message. Clear?
Yes.
Right. So once the environment, runtime environment is ready, then what you need to do? You need to download the RabbitMQ for Windows. So now visit this website, rabbitmq.com, download. Taking time. I don't know why. Okay. So once you install this thing, right, then you will see here you can see Windows installer, right? So these things are there. So what you need to do? So you can see once you click Windows installer, then it will download this one. But I have some that supporting operating system now. Now, here you can see supporting operating system, Windows. If you select, then you will also see this RabbitMQ server. So this RabbitMQ.server 4.1.4, that what you can install. This is the latest one. So once you will install, then you will see this one. So that what I have installed today. But this is the one which I have installed yesterday, RabbitMQ server 4.1.4. So you can install here or you can install from there. So once you install, then what double click on once you download, then you can install it by double clicking on it. So select all the checkboxes, then provide the destination folder where the path, the rate, where the application, where this server is going to install. C program file RabbitMQ server. Click on the install button. And once the installation is completed, you will get this finish installation. Just click on this and that's it. So once this is done, then what you need to do? You need to add the RabbitMQ's SBin folder to the system path. So basically, if you go to the RabbitMQ where it is installed, so you will find this path. See, program files RabbitMQ, this is the version SBin. So this bin path, what I need to do, I need to add again where I need to add in the environment variable. So what I need to do, open this run window, open this system admin, go to the advanced environment, system environment. This is going to be path edit, and here this is I have already added. So let me remove, add new one, paste it, and click OK, OK, and OK. So once we have added these things, that's it. Our environment variable is also added. Everything is ready. So once everything is ready, then what we need to do? We need to start the RabbitMQ service. The RabbitMQ service you can start in two ways. RabbitMQ service you can start in two ways. What are the ways? Using Windows service, using command prompt. So now, if you open the services, then you will see one RabbitMQ service is going to be must be running. So R means see, RabbitMQ is this. So from here, you can stop the service, you can start the service. For example, see here you can start the RabbitMQ service or you can stop the RabbitMQ service. So one, it is you can start the service using the Windows services. Clear? This thing is clear?
Yes.
Yes.
Right. The second option is you can start you can do this by using net start RabbitMQ command. So for example, okay, let me close this one, open the command prompt. Currently the service is down. So now, so net start RabbitMQ. So once you use this command, access is denied. So access is denied. So what I need to do, run this in the administrator mode. Okay. Now, net start RabbitMQ. RabbitMQ service is starting. So once it's starting, then also it is not showing here. Just refresh and you will see it is running. Now, again, if you try to start, already it is starting, so you will get the request service has already been started. So now, if you want to stop, then what you need to do, you need to use net stop RabbitMQ. Net stop RabbitMQ. So RabbitMQ service was stopped successfully. So clear how to start and stop,
Yes.
right? So to check whether the RabbitMQ service is running, running open command, right? So now in the command prompt, type this one. See? So RabbitMQ, right? So currently RabbitMQ service is not running. So we have get this message. So we have to start this RabbitMQ. So what happened? It is running mode. Okay, so we are getting this message. Why? Because we have not set the command, right? Management UI. So to understand this thing, first of all, what we need to do, we need to enable the plugin. So what we need to do, we need to enable the command prompt plugin. So how we can do this thing? So I'll open the command prompt, and this is RabbitMQ plugins enable RabbitMQ management. So the plugin is enabled. So once the plugin is enabled, right? Uh, then what you need to do, you need to start and stop the RabbitMQ services. So once you enable the plugin, so this management window plugin, why it is important? Because once you enable this thing, then you can access the interface. So now we need to step the, so we have to run this one in administrator mode. So stop RabbitMQ. Then again, we need to start RabbitMQ. Okay, so we have started and stopped the RabbitMQ. So once this is done, then what you can do is you can visit the RabbitMQ page. Okay, so this is my local host. This is the default URL. I will show you how to change. So localhost, the username is guest. Password is also going to be guest. So by default, the username password are going to be guest and guest. Just click on this, and you can see all these things, right? Exchange is there, quiz is there, admin is there, right? All these things are provided. Admin direct fan-out header, all these things are there. And here also, right, you can see uh, overview, connection, channel, all these things are there. So all this dashboard, whatever provided, we'll see in detail. Right? Overview, connection, channel, exchanges, queues, admin. So here you can see exchanges are there. Here, right, you can see queues are there. So all these things are how to create and how to configure the right, what type of exchanges, how to add a new exchange, right? What is the type of exchange, right? All these things we are going to discuss, right? So tomorrow we'll see all these things, right? How you can manage that RabbitMQ interface and whatever all operations that you can work for. And once this window, right? Once you understand the overview connection, so basically all these windows, whatever available, we are going to discuss in detail in tomorrow's session. And once you understand this thing, then only I'm going to show you how you can integrate this RabbitMQ within your ASP.NET Core application. Clear? But
Yes, brother.
what you need to do, just to be ready with your RabbitMQ server. So just follow the step-by-step process, install the application, and be sure that your application, right, you are able to access this RabbitMQ. If you are able to access this page, that's fine. So we are also going to discuss how to create right, how to use different URL, how to create different user apart from this guest user. All these things we are going to discuss. Clear? Right?
Yes,
Here is
Yes.
this is admin.
Yes,
You
brother.
can add another user, so password. So all these things are available. So we'll discuss them one by one. Clear?
Yes.
yes.
Okay. So anyone having any question, they can ask.
Pranay, how much of data we can store into the RabbitMQ?
Sorry? Sorry?
How much of data we can store into this RabbitMQ?
See, they are not going to store the data permanently, right? So they are not meant for the data storage functionality. They are basically just a broker. So they will take the data from you and they will transfer data to someone else. So you can store right, as long as right, data you want. And again, if you see, if you think that the application performance is down, then you can create a load balancing environment, right? Load balancing environment in the sense you can make use of multiple instances of this RabbitMQ server. So they see, don't go with this data storage. So they are not meant for storing the data. For data storage, database is there. So they are basically just to transfer. See, what exactly they are doing? They are just taking one message. You are not passing the complete data. So only a message is there. Yes, that request is going to contain some information which is going to be used by the right, what I can say, consumer. But storing the data permanently is not the responsibility of our RabbitMQ. Clear, guys? Okay. So, guys, tomorrow we'll discuss, right, the RabbitMQ user interface.
Hello.
Thank you, guys. Yeah.
So,
Anyone having any?
is it possible for you to share this documentation to help us install and set up RabbitMQ?
See, I will share on my website. I will provide the link, and those who have enrolled to this training program, they will get the document and recorded session. Other people, I will share the link. From there, you can get the documentation.
So how to enroll?
That course fees, okay, the duration is already